So today I want you to ask me any random question that you have ever had about science. Anything. Whether it's physics, math, chem, not math, but physics, chem, bio. Please don't be serious, it can be anything. It can be black holes, it can be subatomic particles, cloning, genetics, anything. I'll try and answer you. Space-time continuum. Alright, wait. Because Einstein is, please. Okay, so Albert Einstein came up with this theory called general relativity. And along with general relativity, it's special relativity and a bunch of other things. But the basic concept of relativity, that was the most revolutionary concept, was like he said space, which is space, and time, which is time, obviously, are not different things, but they're actually interlinked as one. In that sense, you cannot simply say that there is space there, but there is also time there. And anything that happens to the space there will also happen to the time there. You think of space as like a mesh with all vertical lines, and time is a mesh with all horizontal lines. They're all basically overlapped, they're one. You can't regard them as separate things. Like in Interstellar. Right? Okay, so one second. Just to point to this, like make this a little better to understand. So, who knows anything about time dilation? Time dilation basically means the slowing down of time due to some reason or the other. Right? And the great way Einstein did this was through relativity. So, what he said was imagine space to be right. So, imagine space to be this flat sheet, space-time, space and time is this flat sheet. And now we put something with mass in it, like we put this glue stick in it, right? Effectively, what you notice is that this bends, right? This can't stay flat because the mass causes it to bend. Similarly, if you have space-time which is that flat and you put something as massive as the Earth or the Sun or a black hole or something in there, that bend is going to be much bigger, right? You're not following me now? What that means is that mass causes space-time to bend, causes space-time to curve, and that's how we theorize gravity works, and that's how we know gravity works now. So if you take this random flat table and I roll a ball on it, the ball's going to go straight, correct? Similarly, if there was no mass, let's say the moon would just go straight. Now there is mass. So now this is not a flat table, this is now a table curving around with a hole in the center almost. So it's kind of like a funnel, right? Now when I toss the ball straight, the ball's not going to go straight. The ball's going to go like this and it's going to go round and round and round and round and round. To an extent, obviously not exactly this, but to an extent, this is what happens due to gravity. The Earth is trying to move in a straight path. It's just that the Sun has gone ahead and bent the entire space-time continuum around it. So the Earth just trying to go straight. It's like you're on a racetrack and you're going straight. But then someone suddenly just changes the racetrack and makes it a curve. You're still going straight on the racetrack itself, but the racetrack relative to everything else is curved, right? So you're going round and round while effectively you're trying to go straight. That's what mass does to space-time. But here's the thing, I said it was space-time, not just space. Which means that if mass, and I said that space and time are the same thing. Which means that if mass can dilate space, can cause changes in space, it must also cause those same changes in time. Correct? What that means is that as you get closer and closer to mass, space-time bends more and more. And because space-time bends more and more, time gets relatively slower. And this seems like a really complicated concept, but they tried it out and it's true. They put a clock on sea level where gravity is the strongest, right, on flat surface, and then they put a clock high up on a water tower where gravity was minutely, very, very minutely weaker. And these clocks were atomic clocks, which is basically as precise measurements as you can possibly get right now. And they found that the clock on the water tower was moving a tiny little bit faster. The atoms there were decaying a tiny little bit faster than the ones on the surface. Which means that time itself was moving slower on the surface than it was on top. And another reason we know this is because we have GPS satellites, right? What they do is that they see where you're going and depending on which they tell you where to go and how to turn. They need to be able to keep track of the speed you're going, the time it will take you to reach X distance and the distance you're going, right? If you put up a satellite with GPS without taking into account time dilation, it won't work. So the first GPS satellites we had, they didn't work for the specific reason that they never took into account the fact that time actually moves faster for the satellite than it does for the cars down there. They had to make adjustments due to time dilation, due to time itself being slow. So we know it exists, it actually happens. And that is what time dilation is. The closer you get to an object with mass, the slower time gets. Which is why they say if you go near a black hole or into a black hole, time stops. Because it has infinite mass. I do believe time travel relative time travel into the future could be possible in the sense that you do some sort of time dilation to yourself, and so everything else moves faster, and then you stop doing the time dilation, so relatively everyone else aged faster and you did, so you kind of traveled into the future. But in the sense of going back into time, I personally don't think it's possible, but I'm no expert on this. Ever heard of a paradox? Who's ever heard of the grandfather paradox? The grandfather paradox states that, so we have Akarsh right here, and Akarsh is like, I hate my grandfather, he's a piss off, and I don't like him. So he goes back in time, and he's like, I'm gonna kill this guy because I don't like him. So he kills his grandfather. Then he comes back in time. But then he realized if he killed his grandfather, then his father was never born, and so he was never born. So he was never born. And if he was never born, who went back in time and killed his grandfather? That's a paradox. Because it creates an infinite loop where he killed his grandfather, but then he was never born because he killed his grandfather. And that creates this paradox in which situation causes something that can't physically be possible. Right? So either we need to change our laws of the way we look at the universe, or if those are right, then I don't think going back in time is possible, because no matter what you do, you change it a little bit. So antimatter is effectively the opposite of regular matter. What is matter? This is matter. Antimatter is the opposite of it in the sense that other than mass, every part about antimatter is opposite of regular matter. A proton has what charge on it? Positive or negative? What charge will an antiproton have on it?
Negative.
Precisely. Electron is negative. What charge will an anti-electron have? Positive. Now we have this other property called spin. So if a proton has a property of a spin of +1, this is not the actual value, but I'm just assuming, then then an antiproton will have a spin of -1. And because of these, other than mass, the mass as of now what we know is the same. There are theories that maybe antimatter has anti-mass, in which situation it would cause anti-gravity rather than regular gravity. But those are theories. As of what we know of antimatter, as of the antimatter we have created, it is opposite in every sense other than mass. The most interesting part about antimatter is that when antimatter comes into contact with its corresponding matter, it causes a reaction that releases pure energy. It releases no byproduct. In that sense, what you have is when you burn a carbon fuel, you release carbon dioxide. Correct? If you reacted an anti-hydrogen with a regular hydrogen, you would get energy, but nothing would be left behind, because all your mass would be destroyed and converted into energy. So have you all heard the thing that they say that mass cannot be created nor destroyed?
Yeah.
Energy cannot be created nor destroyed. Those are kind of wrong. Mass can be destroyed and made into energy. And energy can be destroyed and made into mass through the equation E is equal to mc square. So E is equal to mc square, so now it means energy is equal to mass into the speed of light square, which means if you take mass of two anti-hydrogens, say 1 and 1, total mass of 2, you destroy them together, your mass is now 0. So your change in mass is 2. Right? So E will equal to 2 into c square, which would be 6 into 10 to the power of 7.
9 into 10 to the
9, a large number of joules, which means that the amount of energy you would get from tiny things would be exponential. Right now, antimatter is the most expensive substance in the world, where 1 gram of it is worth in the trillions of dollars, which is equivalent to the GDP of most countries. Right? So 1 gram of it could pretty much bankrupt an average sized country. Right? So now, how do you store antimatter? That's right. You can't store antimatter in a typical container because it would destroy the container. You store it in a vacuum and hold it through magnetic fields. It does have charge, so you can hold it with a magnetic field. You can balance it by putting magnets in the right way, just levitating it. What a wormhole is and what a black hole is. Wormholes are theoretically things that if you step into one end of them, you will emerge on the other end of them in a
Space-time continuum curve.
Yeah, they pretty much bend the space-time continuum around themselves, so that if you are here, you will suddenly be here. Right? They kind of sort of teleportation thingies, but we don't know that. Alright, to answer that, a black hole is not antimatter, very different things. Antimatter would blow up everything, black holes would suck in everything. A black hole is basically something, okay, remember I told you the heavier you are, the more gravity you create, right? In that same situation, a black hole is something which has an infinite mass in almost zero length, in almost zero dimensions. Do you guys know the formula for gravity? So it's proportional to mass. The more mass you have, the more gravity you have, and it's inversely proportional to the square of the radius, which means the smaller the thing is, the more gravity you have. Imagine something with infinite mass and zero radius. The amount of gravity that would cause would be pretty much infinite, right? So that's the amount of gravity a black hole would cause. So no matter how small a black hole is, the amount of gravity it has will just suck in everything. And that's what you're talking about. So what dark matter is? Regular matter interacts with light. Dark matter is simply a form of matter that has mass but doesn't interact with light. And we know it exists because we looked at this galaxy. And if you imagine a galaxy as this large metal ball attached to a string, and you spin it around and around, eventually you're going to reach a certain speed where the string breaks. Right? We saw that with the galaxy, and we have a certain amount of gravity, and eventually you reach a certain speed at which gravity can no longer hold the galaxy together. Right? Gravity is your string in this situation. We saw these galaxies and we said these galaxies are moving way too fast. The amount of gravity here should not be able to hold these galaxies together. The only conclusion we could come up to was maybe there is more gravity here than we initially thought there was. But we can't see anything that should be causing gravity. So maybe there is something invisible that is causing gravity. And we also know it exists because gravity bends light as well. Like I told you, bends space-time, right? So if you have light going in a straight path and you have a lot of mass here which causes space-time itself to bend, your light will bend around. Right? That happens. So this is what we saw. This is called gravitational lensing. We saw there was a part of light coming. We saw there was a beam of light coming and there was nothing there that should be changing its path. But the beam of light went this and then it suddenly went like that. Why did it suddenly go like that? There was nothing there. Maybe there is this invisible substance there that is causing the light to bend, that is causing extra gravity to be there. That's what dark matter is. They're called weakly interacting massive particles. Basically what they are, in very simple terms, are particles with mass but they do not interact with light.